Today we are going to learn about another special parallelogram. This one's going to be a square. So a square is a parallelogram with 4 right angles and 4 congruent sides. So we know that we have 4 right angles. All 4 angles measure 90 degrees, and all 4 sides are congruent. They are the same length. Because it is a parallelogram, we know that opposite sides are parallel. So I'm going to use my arrows to show that opposite sides are parallel. We also know that opposite angles are congruent, right? All 4 angles are congruent, which means that angles that are across from each other must be congruent. We also know that same side interior angles are supplementary. So these 2 same side interior angles or consecutive interior angles must add up to 180 because all 4 angles measure 90 degrees. We know that 90 plus 90 is 180. Lastly, we know that the diagonals bisect each other. So if we draw in our 2 diagonals, we know that this smaller segment is congruent to this smaller segment, and this segment is congruent to this segment. The diagonals are cutting each other in half. Because it is a special parallelogram, a square has some additional properties of its own. The first one, just like a rectangle and a rhombus, the diagonals are perpendicular. So if we draw in our diagonals, we know that they intersect at a right angle. Next, we know that the diagonals bisect the angles, just like in a rhombus. So because these angles are being bisected by the diagonals, we can actually say that all of these angles measure 45 degrees, right? Because if the big angle measures 90 degrees in all 4 corners of the square, when the diagonal bisects these 90-degree angles, we get 45-degree angles. We cut that 90-degree angle in half. Lastly, we know that the diagonals are congruent. So we can say this diagonal here is congruent to that diagonal. A little hard to draw just because they intersect. So to sum this up a little bit, we know that a square is both a rectangle and a rhombus, and that it has all the properties of a parallelogram, rhombus, and rectangle. Before we move on, I just want to note that here in our square, because the diagonals bisect the angles, you can see that we actually form 4 right triangles, and these right triangles are all 45, 45, 90 triangles. So in our picture, if we highlight our 4 triangles, here we have a 45, 45, 90 right triangle. Here we have another 45, 45, 90, and same thing here and up here. All 4 triangles that are formed by the diagonals are 45, 45, 90 triangles. That's going to be really important for us when we're solving for missing pieces. The area of a square, we have length times width, base times height, or the side squared, because we know that all sides are congruent. So if we say that side is 5 inches, we know that the area is equal to s squared, which is going to equal to 5 squared, which is 25 inches squared. So we're just doing the side squared, or the base times the height, or length times width. All the same formula, just use different terms. Moving on to example 1, we want to draw a square, PETS, with the diagonals intersecting at point D. If ES equals 22, we want to find the following. So I'm going to label ES as 22. Now we want to find the following. So the measure of angle PDS, so angle PDS, we know that the diagonals are perpendicular, so they are going to intersect to form a right angle. So we know the measure of angle PDS is 90 degrees. Next, we want the measure of angle PSE. So PSE is this angle right here. And we know that the big angle PST is 90 degrees. We also know that the diagonal bisects this 90-degree angle, making two smaller angles that both measure 45 degrees. So we know that PSE measures 45 degrees. Next, we have ED. We know that the diagonals bisect each other, so SD is congruent to DE. We know that the entire segment SE or ES is 22. So if we divide 22 by 2, we know that ED is 11 and SD is also 11. Next, we want to find the measure of PE. So that's going to be this side of the square. So what I'm going to do, I'm going to have to use this triangle here to help me find the measure of PE, or the length of PE. So I'm going to draw this triangle below just to make it a little more clear. So we have our right angle. We also know that this is 11. In addition, we know that both of these angles here measure 45 degrees because the diagonal bisects the 90-degree angle. So we do have two 45-degree angles, which means we're going to have a 45-45 right triangle, 45-45-90 right triangle. We also know that the diagonals are congruent. So if SE is 22, we know that PT is also 22, making PD congruent to DT, and those will both also measure 11. So we have our 45-degree angles. We know that this is an isosceles right triangle. So our two sides, PD and DE, are congruent. They both measure 11. Now we can use our special right triangle rules to solve for PE. PE in this case is the hypotenuse of this triangle. So to find the hypotenuse, we're going to take the 11 and we have to multiply by radical 2. 11 times radical 2 is just 11 radical 2. So we know that PE is 11 radical 2, which also tells us that all the sides in the square measure 11 radical 2. For part E, what kind of triangle is angle PED? So we just said it's a right triangle, and specifically, it's a 45-45-90 triangle. So we have right triangle, 45-45-90. What kind of triangle is triangle PET? All right, so if we look at triangle PET, that's this blue highlighted triangle here. We know that angle E is a right angle. We know that angle EPD is a 45-degree angle, and we know that ETD also measures 45. So again, we're going to have a right triangle, and more specifically, a 45-45-90 triangle. Remember, all the triangles formed in a square are going to be 45-45-90 triangles. Moving on to example 2, we want to find the values of x, y, and z and w. So let's start with x. We know that the diagonals are perpendicular, right? They intersect to form right angles. So we know that x measures 90 degrees. We also know that the diagonals bisect all the right angles. So they cut these right angles in half. So we know that all of these pink angles with one arc measure 45 degrees. So we know that y and z both measure 45 degrees. So again, we have a bunch of 45, 45, 90 right triangles. We're going to see this a lot with squares. Lastly, they want us to find w, which is going to be this side of the square here. So the triangle that'll help us find this out is going to be this blue highlighted triangle. I'm going to draw it out separately. So we have our right angle. We know that angle A and angle D are 45 degrees each in this triangle. We also know that DS, segment DS, measures 14. So we know we have an isosceles right triangle, right? So if DS measures 14, we know that AS must also measure 14. And then to solve for W, we can use our special right triangle rules. So we have W equals 14 times radical 2, and 14 times radical 2, we're just going to leave as 14 radical 2. So W is 14 radical 2, which means all sides of the square measure 14 radical 2. Next, we want to find the area of the square. So first, we have to find the side lengths. We know that the diagonal here is 16 centimeters. We know that all the sides in a square are congruent, so we can label both sides as x. And we also know that we have a 45, 45, 90 right triangle. So if I draw this triangle out separately, we have our right angle, we have 45 and 45, and we have 16. So here we can use our special right rules for 45, 45, 90 triangles again. We're going to do x equals 16 divided by radical 2 because we were given our hypotenuse. So to work backwards, we have to divide by radical 2 this time. We can't leave the radical in our denominator. So we're going to have to rationalize here. We get 16 radical 2 over radical 4, which equals 16 radical 2 over 2, which equals 8 radical 2. So now we know that the sides of the square measure 8 radical 2. So to find our area, we're going to do 8 radical 2 squared. So we get 64 times 2, which equals 128 centimeters squared. That's going to be our area for the square. Last one, we have the area of a square measures 72 inches squared. Find the length of its diagonal. So we have area equals side squared. So first we have to find our sides. 72 equals side squared. We're going to take the square root of both sides. Here we get that a side equals the square root of 36 times the square root of 2, which is 6 radical 2. So if we draw a little picture for our square, we get 6 radical 2 for the sides. We know that we have a 45, 45, 90 right triangle. So to solve for our diagonal, we're going to do 6 radical 2 times radical 2, which is 6 radical 4, which is 6 times 2, which equals 12 inches. So after we found the sides here, by using the area formula, area equals side squared, we used our special right rules to go from the leg of the triangle to the hypotenuse. So we multiplied by radical 2 here. 6 radical 2 times radical 2 is equal to 12 inches.